I'm Alice. I'm the founder and CEO of Recollect. My background, I've been doing machine learning for about a decade, and before that I was a cognitive neuroscientist, so yeah, you can expect that.
Hey, my name is Linus. I was in previous life a web engineer doing like JavaScript, UI engineering, that kind of stuff, and then more recently I dipped my toes into how to use AI to work on tools for thought. More specifically, how do we improve the way that we record and represent and communicate ideas, so like the actual representation, more so than like the tools that we use to work with them.
And I'm Chris. I come from a product background. I was the founder of a startup called Socratic. We built an AI tutor and Google acquired it, and I have been jumping into the tools for thinking space recently because of the ML connection. So I have a hypothesis that a reason why there are so many builders interested in the tools for thinking space today is because the potential for machine learning is so palpable. People have been trying to build tools or have been building tools for a very long time in this space. What feels different to me are the new capabilities due to machine learning. Alice, do you want to just set the stage and tell us like what's happened over the last few years that has changed what's possible?
Absolutely, yeah. So I'm not going to get into great technical detail, but I think some of the major things that have changed, some of you might know about. So we have one thing is these large language models now that have been pre-trained that are accessible to lots of people. There were a couple of innovations that happened around 2018 or so that allowed for this. One of them was, we had these large transformer models. We also had transfer learning. So for the first time in a really long time, I've been doing this a while, we were able to, as say startups or smaller groups, really harness the power of these big models that were trained otherwise. So that was a major point of shifting in the environment. Another thing that was kind of a slower burn over time was that we were able to have people that didn't have, say, a PhD in machine learning use this information. So we had lots of tools that we're building for different reasons to allow more people to use these models and to use them and build them into tools without necessarily having the deepest of expertise. So I think those are two big shifts that we've seen in the last couple of years that have really changed the game in terms of what's possible.
I'll elaborate on, so I think you covered it pretty well. I'll elaborate on 2 points that I think are personally interesting to me. One is the fact that, the new thing with models like GPT-3 is that we're doing extremely large-scale pre-training on like internet-scale data sets, like 10% of the internet, which is a lot of text, which means, and the thing that we've discovered is that as you scale up these data sets and these models, they just continue to improve at a pretty predictable rate, which is sort of a thing that you might not expect necessarily, but we've discovered that as you just scale these things up, they just become smarter and smarter, seemingly without bound, or at least nothing that we've hit yet, which I think is how we've got to GPT-3 here today. The other thing that I think makes it possible, and makes GPT-3 so interesting is that large models generalize really well. So they generalize in a few ways. One is what you mentioned on transfer learning. So you can have a pre-trained model that you then fine-tune or few-shot prompt to do specific things. So a model may not have been trained to do something like classifying your personal notes, but you could give it a prompt and it can do it, and it can generalize in that way. Or you can fine-tune for something like the demo that I showed earlier. It's like a fine-tuned language model, and like a solo researcher like me can do that because they're pre-trained models that already have had lots of resources invested into it. And so I think all of that just makes models more capable and also more sort of just accessible to lots more people.
Great. Well, we saw your demos earlier. I'm curious, what do you see as the high potential applications of these technologies to the tools for thinking space? Is it helping you write text? Is it summarizing lots of information, organizing it for you? What are the different kind of opportunity areas?
Sure. So I have a kind of a spicy answer to this one, which is that I think a lot of people are focused on prompting. So people are focused a lot on GPT, like text generation, models that continue text, and specifically on giving it prompts that it'll continue, because prompts are sort of the most accessible, easy to wrap your head around kind of way to control these models. And prompts are cool. They're like sort of very in vogue, but I think prompts have the downside that they're kind of a skill you need to master, and they have hard to predict sort of discontinuous performance. So what I mean by that is you can take a prompt that is pretty good and change a couple words and it can suddenly suck. And it's hard to predict exactly what prompts are sort of the perfect ones for you to use in a particular case. And so it requires a bit of skill and a bit of trial and error to find the right prompts. And I think the more fundamental capability that modern language models give us is that computers just now understand language at a human level or better for a lot of tasks. And that means that beyond prompting, at a higher level, you can expect computers to do things that they're only able to do when they understand what you're writing about in natural language. So one use case that I like to think about a lot is like, because computers have this new fundamental capability, you can start to build interface abstractions, assuming that computers understand text. So on all of your computers right now, you have files. They contain text. The interface assumes that the computer doesn't know anything about what's in any of those files. They're just files. They're opaque, sort of like blobs of data bytes on your hard drive, and you have to tell the computer what they're about. You have to tag them, categorize them. But you can imagine interfaces where you can expect computers to automatically categorize them, automatically group them, cluster them, and I think that potential to build interface abstractions, assuming the computer understands all of your text, is like exciting part.
That's awesome. Alice?
I was listening so intently, I've now lost the thread of what the question was. Yeah, I kind of want to dig in on like how what understanding means there. But
dig in, yeah.
I mean, yeah, I don't want to take us too far off the point either. But we're talking about these sort of new capabilities, what we really think they're unlocking.
Yeah, exactly, what they're unlocking. And it sounds, I'm going to try to put what Linus said in lay terms, then you can pick it apart, which is,
I don't want to pick it, okay.
Instead of understanding, it's like, instead of working with words, computers can now work with meaning.
Yeah, that's the part that's a little bit trickier for me.
So let's talk about it.
Yeah, so I mean, I think these language models are fantastic. It's exciting that we have them. I see them as like one component of a lot of different things that we can bring together and different methods we can bring together. How much they really truly understand and at the conceptual level and at concepts that we would, as humans would say are accurate is still, I'm not quite there yet. So like when we think about, one way I could extrapolate from what you were saying, Linus, would be, I'm writing these natural language commands like I write and say, create me a computer program that, like for recollect, I could say, make a computer program that mimics my memory. And I would expect then that the sort of language models would be able to take the meaning from that and then be able to coordinate with other software programs to execute on something like that. Would be like the farthest I would take that. Which I think it's not totally off, but it's not completely there either. I think we have a little bit more human in the loop and a little bit more of this sort of questioning what is the language model without making it so anthropomorphized. Like, what is it really taking out? Can we start to get a handle on that? And pivoting that, I guess, into my answer, some of the directions where I'm excited about this going are really, like, I think they're unsolved problems. So I think when we talk about human concepts, I'm very interested in this idea of individual human concept formation. We can study how humans do this and how they develop these ideas over time and concepts. It's actually pretty complicated, but we can start to model that and we can start to find or look for ways to use maybe not even large language models, but a combination of different kinds of models to pull that information out. But to me, we're still sort of stuck in like a middle zone, I guess. Not to say that we won't get there eventually.
Do you think that the gap that exists in understanding is more a problem of do you think that problem can be solved by improving the performance of models more, or is it more about interpretability and understanding the way the models understand?
I think we still might. So I'm not sure we need a completely different kind of model. I've seen the performance gains and I agree that they're really remarkable. I think that adding more parameters to a model or adding more data is not going to get us to this. Really, what we're talking about is a sort of AGI, right? Like, we're not going to get there with that, I don't think. So we'll either need to have some other kinds of advancements, or I think a more likely, not AGI state, but before that, right, we have a combination of different kinds of models. So when I think about building systems like this, I'm building them the way a human would work, and so I would have one model that's really dedicated to language, one that's really dedicated to vision, one that's dedicated to sort of higher order control of those systems, right? Like, I look at it as like a component system that we would want to put together. So if I just rev up my language modeling in a human or in a machine, like, I'm just not going to get totally there. I need these other systems.
Okay, so one question for the builders in the room. If you're going to go out tomorrow and you're going to build something in this tools for thinking space, can you talk a little bit about what are the limitations that exist today, and from very concrete terms, and which of those might change over the next couple of years?
I can start this time.
Yeah.
There are some limitations that exist today. One of the major limitations still really is having labeled data sets. So when you talk about, any person coming up and picking up one of these models, a lot of the fine-tuning really relies on having label data from the task done. That's changing over time too. We saw the same kind of trend when we looked at deep learning, really needed all of this label data, and then we got into more unsupervised methods. But I still think it's a limitation today. So having enough labeled data for the specific task that you're doing is going to still be a problem when you're trying to fine-tune these models, if you're trying to fine-tune them. So I think that may change over time, and I've started to see this in some of the literature as well. So people are thankfully taking lessons learned from this revolution we just had with deep learning models and kind of starting to apply that and saying, okay, what can we do in an unsupervised fashion here? So I think that's one limitation today. Another is the interpretability, and that's changing really quickly. I'm sure Linus has a lot to say here, so I won't dig in too much. But just around when we have these generative models and we're trying to interpret, when you look at the results, sometimes you're like, why did they do this? So as humans, we're trying to inspect the output of a system we don't have access to, and that's really hard. And so I think it is a limitation today, and it causes a lot of friction in some cases. But I also think that will change over time. So, again, applying some of the same methods that we've used in the past to probe deep learning models, I think we can apply here. I think we'll come up with new ones. But yeah, and if you're a practitioner just getting into the space, I think there still is a hurdle in really deeply understanding how the models work. So you can grab something off the shelf, you can grab GPT-3 and try to plug it into an application, but it's going to make a lot of these errors if you don't understand how the model was trained. If you're trying to swap out models, like a new one comes out and you just plug it in, if you don't really fundamentally understand, was it a masked language model? How was it trained? What kind of data was it trained on? Those are not interoperable in the way that you kind of hope they would be still.
Continuing on from the interpretability thing, I think one challenge that is closely related to interpretability is controllability, and in general, being able to rely more on, if you give this input, as a human I would expect this output, and it indeed does give that output, and alternatively, if you don't like the output, how can I steer the model more towards what I want? And that's not always straightforward. Controllability is something that I looked into a lot while working on the demo that I showed in the earlier session around how can I finally, I'm trying not to say fine-tune, how can I finally adjust the output of model to be like, maybe I like the output to this prompt, but I want it to be a little more formal. I want it to be a little more factual or a little more casual or something. The current interfaces we have to these models don't afford us that level of smooth, continuous controllability. And because of that, maybe, we also don't necessarily know how to guide the model towards more important things like making sure that models aren't racist and they don't have certain kinds of biases they want them to avoid. And so controllability, interpretability, I think are closely linked, and that's almost every company that takes GPT-3 output and surfaces it to users has this problem of they have to put a disclaimer on the product page that says, this is from a model. If they say something offensive, that's because it's a model and we don't know how to control it, which is, I think, a long-term problem we have to solve.
I agree, yeah.
So an interesting thing, I think, for folks starting startups now is there are these really good general models, right? And then there's a lot of extra work I can do to do something bespoke. So how do I think about what tech stack to build on top of, what's going to change, what can be easily replicated by my competitors, and how do I think through the strategy? Alice, you've gone through all this. I don't know how much you want to share about Recollect, but I'd be curious about your tech stack decision-making process there.
Yeah, so I won't give away the entire product, I promise. Hello, folks on my team. I think I'll speak generally and then I'll speak about Recollect. So before I started Recollect, I actually spent a lot of time advising companies on how to build machine learning products. And this was actually back in, 2018-ish, when all this stuff was changing with the language models. So I think if you're a small company, there are a lot of considerations to make, right? You don't have a ton of data available. This is still a problem, like we just talked about with some of the fine-tuning. And so I think the considerations here are, can you find a model that's either off the shelf, or you can fine-tune, or you can add some rules to, or you can start to stack different models together. But they have to be small enough, and they have to be quick enough, and you have to be able to run them on infrastructure that you can basically rent, or Amazon and Google will give you credits for these things. But I think there is a limitation when you're just starting out that you're not working with Google's scale or any of these other big companies' scale infrastructure. In terms of the actual tech stack you use, there's a lot of stuff that's come out recently. For every piece of data transformation, data pipelining, serving information, serving the, if you're doing some sort of UI on it that's more machine learning based, they're all fantastic. I think there are a couple of big obvious players in terms of where to store the data. Thinking about designing your system in a way that's going to be computationally feasible, I cannot emphasize enough. Like, you can create a really awesome demo that used I actually accidentally did this weekend. Sorry, Andre. That you run for several days using GPUs, and you're like, this is not feasible in production. I could never put this into production as a smaller company. If you're at a larger company, you have a different set of restrictions to work with, right? Like, you have probably different ways to access data from the customers. It's more of an onerous process to get approval and to work with the right product teams to get all that stuff through. At Recollect, we're using a pretty simple tech stack. We think about the way that we differentiate as a startup, not necessarily as creating like models from scratch. Those are actually hard to do with not a ton of computational resources and easier to like steal than you would think. So for me, when I think about the defensibility, the moat, what you're building, it's really about how you put the things together, just like it would be for any other product that you're putting together, right? Like maybe you have specific hyperparameters you're using and you do some sort of like magic there. But it's really about how if you have competitors in the same space, it's really about how you break down the problem and try to find the appropriate model for each piece of it and put those together in a unique way. I think I answered some of your questions.
I think a concise way to summarize the last point that you made, which I think is really important, is that the model cannot be your product. Your product cannot be just the model. And I think in the early days of GPT-3, I saw this a lot where someone would just like slap a prompt in front of GPT-3 and be like, this is our product, yes. That I think is, well, one, as you noted, that's actually not as defensible as you might think. And I think from a more just like personal perspective, I think the higher leverage side of this space is in the interfaces and how you let people interact with these models, maybe how you gather the data that maybe you have unique access to train better models. And all of those things can add to defensibility, but it cannot just be that you have better models, maybe you have access or you have more compute. And also, yes, GPUs are, it turns out, very expensive.
Yeah, that's actually a point I want to double down on. I asked you a minute ago, hey, that demo you showed earlier, which is so cool, could you just put it online so we could play with it? And you said, no, it would be really expensive. So, and that's, sorry, go ahead.
Yeah, so the demo, it was running in sort of real time. I was feeding it inputs and it was streaming back the outputs, and it was painting that one GPU dead 100%. And so if there was another person on that same server, it would literally slow down by 2x. And so not feasible.
And, yeah, go ahead.
Oh, that brings up a really good point, yeah. So, yeah, my specialty is sort of like taking research stuff and applying it into products that can work in real time. So this is a real problem, right? Like if you're trying to retrain something on the fly, you're dead in the water. Like you're gonna use a ton of compute to do that. So when you're thinking about these things, you really have to think about like what can you do one time? And then like what small incremental piece of it could you have updating? Maybe you do bulk updates overnight or something like that, but having something that's really happening in real time and retraining anything in real time is just really going to, cost you a lot of money, or you can have these like huge time lags that don't make any sense for a product.
I think this is also where like the model size and data size versus efficiency and cost trade-off comes in, where if you can afford it, you can use the largest OpenAI model for sentence embeddings or text generation or whatever, but then that's going to cost you a lot of money. And usually this is a thing that I'm learning currently, there are cheaper ways to get the same amount of performance, especially if you have a specific task that you want to do. There are way cheaper ways to get the same kind of performance by doing a little more extra training or just like Googling a little more if you're like me and you're just getting into ML. There are ways to eke the same amount of performance out of smaller models, cheaper models that can run much more cheaply, and those I think are important to look into.
And I'm not letting anyone go before saying, don't use models unless you need them. Try your best to do it without these expensive or big models. Really, you can get a lot of the way there, and it's just, it's a really sad, bad path to just like start with the most complicated thing.
Big models are also really slow, and slow UI is always bad.
Mm-hmm. if you're building a startup, you have to kind of make some bets of where do you put your attention, right? So you can try to minimize cost today in these different ways. That can take a lot of time. But if you look out and say, what's the general trend? Is this going to get an order of magnitude cheaper over the next 5 years? And if so, am I willing to eat that cost? Or is that a really bad path to go down? Like, how would you think about the general, like Moore's law of compute cost for this type of work?
It's a really tempting sort of negotiation with yourself as a founder to say, this trend is going to continue. We're going to see these decreasing costs. Like, I'm pretty sure of it. I mean, I think it's a bet you can make. And, you know, even lots of companies not using machine learning, like Lyft, right? Like, they were like upside down forever, right? And so they just hoped that things would get cheaper, something would change, and they would be able to write themselves up that way. We all just pay a bunch for Lyft now. So I think it's something you can do, and you can do it for a while. So there is this like increasingly cheap compute, but the models are also growing at the same time. So it's no longer the situation where, you know, we're using kind of the same amount of compute power, same size models, and like everything about it is getting cheaper. So I'm thinking of what is it, Hamming's art and something you're doing. And anyway, there's a book and they talk all about this, and like you can actually model out like what that should be for these different kinds of components over time. And I think it's pretty accurate in the way we've predicted it. But if the models continue with this trend, I don't think that is the smartest bet. I wouldn't make it.
Great. Moving to a different topic. The different demos today have shown different models of interaction with these capabilities, right? So text completion is kind of the table stakes where we've started out. There's been talk about AI agents. Perhaps they collaborate with you. Imagine two people in a Figma file, like jamming on something, except one of them's not a person. Or a review process. You write an essay and you kind of send it to an AI editor and they get notes. Where do you think we're headed with those interaction models, both from like what you've done yourselves on your own products or explorations, but just what you see happening in the industry?
Yeah, so we talked about this a little bit at the beginning, and I think you said some really smart stuff about anthropomorphization, so I'll let you maybe touch on those. I think one interesting space that people are not thinking about as much as they should is that sometimes the best interface for really clever models is just as a part of features that are kind of invisible. So instead of exposing the model output, like text generation or whatever, directly to the user, you can just use the fact that these models understand language to some extent, and put it behind a clever button or something like that. So if you have a search engine or a search system of some kind, you can just have a better search, and it's sort of invisible, right? Because you're using the same kind of search features that you would have used maybe before, but now the search is just automatically a little bit better because you're using a model. Or if you have like a photo editing product, and you can use a model to enhance, maybe like suggest filters or let people search for filters or styles with text or something. There are lots of different ways to, I think, make sort of classic software features a little bit incrementally better by making it more amenable to natural language control or just surfacing it at the right time, things like that, that sort of bury it in an invisible way behind sort of classic sounding features. And I think that's an underexplored area.
Yeah, I agree, and I think we're already, like, if we take it away from natural language for a minute, too, I mean, this is really something that's already baked into a lot of the products that we're using today. So a lot of the products we use are taking the data, our usage data, and learning from it, and they're changing our experience over time. So that's really how machine learning models work in general, right? They bring more information, and they change things over time. So there's a lot of things that you could build in that sense, in terms of the interaction, that really are invisible. So that's a great point. I hadn't thought about the, like, really invisible, like, this thing is actually doing something without me knowing it almost.
Like autocorrect or spell check.
Yeah, and even better if that autocorrect or whatever it is taking my information over time and getting better. Like that's sort of, and we talked about this a little bit this morning, I won't go down too far down that rabbit hole, but like if it's learning from my data and it's changing something that's specific about me, especially in the tools for thought space, if we can start to take like our underlying knowledge, we have all this stuff we're storing, we're collecting it, if we can start to have it change based on what we actually know, not just like this blanket sentence completion, I think that's really one of the paths that I'm very excited about, sort of auto-completing your actual knowledge. But going back to the interface question, I think we do have this tendency to anthropomorphize these tools, right? Anything with language, we don't have a concept as humans of something that can speak to us that's not a human. doesn't exist ever in time. So it's really irresistible when we get this output to be like, oh, and you almost immediately ascribe a personality to this thing. You can find it funny or ridiculous. You can find it very serious or spooky. All of these things we're doing really quickly. So I think it's very difficult to design interactions that make it clear, A, that you're talking to an agent or a thing that's not a human. So I think we need to do some work there to make that obvious to people so they don't sort of get tricked in a sense into thinking that way. And so there's a couple of different metaphors we can use. We can use an assistant metaphor that's sort of like working for you in a sense. We can use a collaborator metaphor where you're kind of working side by side. And something we've been tossing around and thinking about at Recollect too is sort of more of this extended mind metaphor too, where it's really a part of you. It's not a separate thing. It's not a separate agent, right? Like we're taking something that's really intimate to you in a sense, your notes, what you're reading, what you know. And if we do create this extended mind, then it really should be you. It shouldn't feel like I'm talking to you even. So we've been thinking about a lot of the different ways we could interact in that way.
Third thought that I will add is that if you expose the interface, if you're working with language and the interface that you expose is text generation, reading is kind of tiring. People generally don't like to read more than they have to, and if your interface to like expose information or give people search results or recommendations or things like that, if that is just making them read more stuff, there might be better ways to expose that information using maybe like categories or icons or other things like that, other than taking the output straight from the model. And I think because these models are so good at just generating mountains and mountains of text, and you can just mechanically do it with compute, I think it's tempting to just expose that output straight to the user, but text generation, just from a pure interface perspective, is, I think, also sometimes not ideal.
When I started playing with the different products in this space, I thought the limiting factor would be the ML, but I actually found that the interface design was oftentimes the limiting factor, where I get this really good text results back, but there's a mountain of text, and now I have to read through more text than I had before. So the very specific question is, what can we do about that, right? Because thinking is like, we still use written word as a proxy for thought, and lots of thoughts are out there. How can we, any ideas on how we can compress that and make it more easier to process?
One way that I've thought about that question is around so humans are really good at navigating spaces. It's one of the things that like our brain's really good at. You're the cognitive science, like neuroscientists. But our brains are really good at navigating at least two-dimensional, three-dimensional spaces. And so what if we make sort of information-heavy tasks like search or like reading your way through a long essay or something more like navigating a space? And using NLP, I guess, there are, I think, clever ways to turn things like deconstructing the structure of an essay into more of a spatial navigation task by projecting it into kind of a canvas view in some way, or like a hierarchy of points in some way. And I think they can help people decide which branches to go down or what points to look at and focus more on. One of my experiments that I did previously in the year was around like summarization and how to let people take away sort of quick gists of information out of long pieces of text. And the straightforward answer to that is maybe text generation, where you just give it a model, an essay, and it generates a summary. But then you're just creating more reading tasks, and the summary might not necessarily encapsulate the information that you're looking from the essay. So a solution that I came up with was, what if you just have the model highlight the parts that it thinks is important? And when it's not sure, it just like highlights with like a lighter color. And so you have this sort of heat map over text of, it's the strongest where the model thinks it's the most relevant, important information, that's the most key, the meat of the essay. And then when it thinks it's less confident, it's less weakly highlighted. And humans are really good at scanning for color and for accents. And so those kinds of interfaces where you turn information tasks into navigation tasks or filtering tasks visually, I think are interesting.
I think that's super interesting, and I think I'm pretty convinced that we're gonna have to invent new interaction or UI paradigms to unleash the power of these models. If there are folks out there thinking about that, I think it'd be great to create like a group, like community of practice. So just like reach out to me on Twitter. I'll create I don't know what forum, a place, but we can get talking about this.
On Plexus.
What? On Plexus, yeah. What were you gonna say, Alice?
Oh gosh, I'm gonna try to remember now. So I was gonna say that I think that like it's a great idea to use these other systems that we have that are really good at pulling gist information out. We were talking about this a little bit earlier today, but it's very easy for us to pull the gist of information out of a visual scene. It's very difficult out of text. I was talking about a little bit earlier today in the demo, right? Like once we abstract these things to be in this like one-dimensional or two-dimensional plane, I guess, we lose a lot of the spatial navigation that we would rely on otherwise to think through things, to find things. So any way that we can bring that back, I think, is a great idea, to rely on these other cognitive mechanisms that are not so slow. And I think for me, the way I've thought about this, summarization is one way to do this, but if you take out-of-the-box summarization, it's hard to do with multiple documents or multiple bits of text that are unrelated to begin with. Like, it can be hard for the model to generate coherent text from that.
If you group them together or independently?
If you group them together and try to summarize over it, right? Like if they're from, like for our product, right? Like if I had cards from like 7 different articles, like I would love to be able to come up a level, is the way I think about it, is sort of like, can I get that gist representation that I can get with images? Can I get that higher level representation? It's probably going to be a text-generated summary at some point. But to Linus's point, the way these models work is actually before they can get to that stage, they have to decide what's important. So they highlight the relevant sentences, they pull the relevant sentences to do at least extractive summarization, right? But another thing we can do is not just rely on the machines for this stuff, right? I, as a human, could highlight things intentionally and say, these are really important from this article. I could write something around it. Like, I think if we start to encompass all of that, we'll end up with this shorter generated text, but the more context we can get, the more we can get the human involved in the process, the smarter those generalizations will feel, and less like, this is just a summarization we would all agree works for this article.
Great, one last question and then I'll open it up. We're talking about building tools for thinking, and we're talking about using these machine learning models that we can't look inside of and fully understand. Where are the places where we should tread lightly and be careful? And where are there places we could have unintended negative consequences in potentially how people think, or what if they trust the models or the products blindly? How should we proceed and think about that?
The most important part of this for me goes back to what Alice alluded to earlier around when humans work with systems that talk back to you, we implicitly assume that A, that maybe this is a human that we're talking to, maybe we can trust them, and also B, especially if it sounds smart, we implicitly, maybe subconsciously take it as kind of an authority on the subject. And even in sort of classical software, a lot of us learn to use programs by just sort of clicking buttons and seeing what does what, and we sort of trust that if it does a thing that seems right, we trust that it's right. And I think as we build more information tools on top of language models, that problem can be exacerbated. So we may build language model or model-powered features into these tools that people learn to implicitly trust when really they should not be. And we can't just tell the people don't trust it because people never really listen to instructions. And so we have to think really carefully about how do we design interfaces that make sure that when people take information out of these systems, they know what to trust, they know what to be careful of, they know not to take these, they know to take this information with a grain of salt. And that's, I think, an important and hard interface problem.
And on the modeling side, I mean, this has been talked about a lot in the media, especially recently. I mean, there's a lot that goes into AI ethics. It's a growing field right now. I think whenever you're using machine learning, when you're using a system that can change on its own in a way that isn't obvious to you, you have to think about really what the worst thing that could happen would be. Like, if this went totally rogue, what would happen? I think the example I used earlier today is that it would sort of subtly convince me to be a fascist somehow. So like, you have to think about these disaster scenarios. You can't really prevent them per se by like mapping all of them out on a whiteboard. But some things that we can do are thinking about what is the training data that went into these models. A lot of it is like Reddit, not a great place. For a lot of things, it's great for other things. Thinking about the information that goes into training these models, thinking about the people that are building the models, and I don't think we touched on that this morning, but I was thinking about it afterwards, and that, we have, the diversity is still pretty bad in the people that are actually training these models and putting this information together, but you really need to have people from different perspectives, different cultures, different languages. They really need to have input in creating at least the base models that we're all using, and we're all adapting for other things. And we also talked about, the agency or whatever, Google makes this model, it gets out into the world, or OpenAI does, like they're not really responsible for what all of us do with it afterwards. But the more that we can think about these questions of like, what is the most evil thing this could do? What's the underlying architecture? What went into this thing, the better to at least sort of stave off some of the worst things that can happen with these toxic chatbots.
The foundation models idea that you touched on reminded me of an important idea that increasingly we're seeing this trend of few large, well-funded, well-resourced organizations training very large models that are very capital intensive, millions and millions of dollars, and then everybody else uses them as the foundation for their own kind of fine-tuned model. And that creates a kind of scale effect where if you have these largest organizations creating models and getting a lot of the benefit and creating bigger and bigger models, then any sort of small bias or small unexpected influence that these models have at their base layer can filter their way down all the way through the rest of the ecosystem. So I think that's an important challenge for the industry to think about and tackle.
All right. Questions? Don't know where to start. Yeah.
Okay. All right. I'll try and make this brief. It's going to be a little broad, but let's assume that the interface problem has been solved or is well on its way. I love the demo. That's exactly how I've been thinking, so both demos are fantastic. And it speaks to a pattern that I see with prompts of being very input-output based, I/O, right? And so let's assume that that's been expanded and delineated, and now there's spaces in between the input and output. And that might look like, say, intonated text on your phone when you're texting. You could do a swirl or a hard press, and it like the machine knows, okay, that was meant with some skin on it or whatever. I could see us getting into a place where we are changing how we use our tools to give a small data model more information about our meaning. The question I have, first off, I'd love to know your thoughts on that whole region. But how do we get there? Because the weird part about declarative models or standard interfaces versus ML models is that we don't seem to adopt them until we get results. So from that perspective, or the amount of effort we put into, say, DALL-E is very low, right? It's not going to screw anything up. We can just see what comes out of it, and we either get a reward or not. But if we're talking about a more complex interface where it's passively learning our preferences and our semantic structures, how do we get people to start using that before we can provide good results? Does that make sense?
I think it's up your street, Allison.
Yeah, I'm going to give my answer and then I will pass it. Okay. Yeah, so this, I think what Chris might be alluding to, so I love the idea of the long press type thing. I hadn't thought of that. So I'm a big proponent of getting more information from the human that's interacting with these things. And I think you're down the right path, right? A way I've thought about this is, given my background, thinking about brain-computer interfaces and how do we start to get some biological data in there in terms of a response you're having. So when you talk about the long press, what I'm imagining is a change in your intonation, right? Like you're giving it some emphasis. So I think the more that we can start to imbue these models with that, the better, in terms of really getting to be a part of interaction. The second part of your question, though, which was, I think I'm saying, and correct me if I'm sort of getting the wrong angle there, around, DALL-E is sort of an experiment, it's fun, it's like very low cost. If we get results, it's kind of entertaining in that sense. But the more we move towards models that are going to be like integrated into our daily life, they're going to be more serious. I think part of your question was sort of like, how do we start to think about that? How do we start to bring all of these pieces together?
Yeah, how do we get adoption when the threshold is higher?
The threshold is higher for the output to be something useful or something that they can kind of see and feel and understand?
Let's say I'll take another.
Sorry, just perhaps we should move to the next question because there are a lot of hands. Sorry. Yeah.
Yeah, I have an addendum to what you were talking about earlier, in terms of the important thing to keep in mind is that there is no understanding of concepts on the side of the model like GPT-3. And you see this actually surfacing in the discontinuity that you have in the output that is generated, if you look at what you did previously in the demo. And if that were the case, if there would be an understanding of that, it would also be easy to guardrail those models against doing things you don't want. So you could just tell GPT-3, hey, I want to have output, but don't be racist. So that understanding is not there. It's just statistics. It's not human, as we humans understand concepts, is not in there. And I think as a corollary to that, there's going to be a diminishing return on being bigger. So I think once this scaling with more data should taper off at some point. Mm-hmm. And I think we're getting close to that point. Personally, that's a bet. So I think what will be happening is we should be getting smarter about what we can leave out. So which statistics we get diminishing returns with more data at, how can we change the structure of those models? And how can we imprint concepts onto the output of these models by using knowledge that we have, so facts about the world.
Thank you. Just choose someone. No, it's all right.
Thanks. Alice, you mentioned this point that text is very self-similar, and a lot of the notes end up looking the same, or the snippets, right? And then Linus, you said we could use AI to possibly color text. I think the fact is that most Notion docs, Rome Research docs, Google Docs basically look the same from a distance, right? So if I'm curious, what have been your thoughts on, for example, using a large language model that then, for example, creates a symbolic representation for a paragraph, right? And adds that so that from that point on, that space is always represented by that kind of symbol, and you can see it from a mile away. So basically these kinds of UI integrations that change the experience. What do you think about that?
Yeah, I think that's a really interesting space for exploration of imbuing the model with higher level understanding of document structure. If in your data set you have enough structure to do that. I think just because of when you train these large models, you're scraping across the entire internet, and there isn't really any reasonable structure you can pull out. But I think both when you're training models to work with structured documents, and also in general when you're designing interfaces, even without the AI part, when you're designing interfaces where there's a lot of repeated structure, that repeated structure in the document is probably a hint to the UI designer that maybe some of that should be refactored out into a table or some common view or something. And so I think in general, when there's repeated structure in text, it means that it could be factored out into some common abstraction in the interface.
I think he was actually kind of hinting at what you were talking about earlier, though, where you're trying to represent this lots of information, right? So we talked a little bit about images you could put inside the text, but you have a much broader thesis there, I think, around how to represent textual concepts and visual images. I think that's where
could you replace a paragraph with a DALL-E glyph that captures the essence of the meaning that you could quickly scan?
Yeah.
Yes.
That's why we're nodding at you vigorously.
We're just putting words in your mouth, but
Not replacing, just side by side.
Side by side, okay.
Yes.
But still.
Yeah, that's my goal. That's good. Good idea.
you guys should talk. Yeah.
I think this is our last question.
Last
okay?
question, yeah.
Yep.
2 minutes.
Thank you. That was super interesting. I have a question about the way in which tools expand our intellectual abilities, and I think that there's this common theme around intellectual tools that the abilities that are amplified by the tool are also diminished in the human. And as an example, I think maybe 1,000 years ago, 500 years ago, I don't know when the clock was invented, the mechanical clock, but the moment that you have a device that tells time, you kind of lose your intrinsic sense of time. Yeah. Or I think you can see it every day when people that exclusively use Google Maps to navigate streets aren't great at navigating without. They kind of lose the ability to navigate streets on their own, or their sense of orientation. So if we're building tools for thought, how do we make sure that we are the ones that are becoming smarter and not that we're making smarter tools that make us dumber?
It's a great last question.
Yeah. I think you nailed the examples of this. People often talk about GPS as the thing that's made us unable to navigate now. And this is one of the best I'm going to keep saying extended mind because I really like this sort of theme and this philosophy around this, but we've really outsourced this information. So I think we need to really level set on what we mean by smart and what we mean by like augmenting our intelligence in general, right? So if we are able to offload some of our information or some of our thought to either, you could say that if I write something down and I'm not committing it to memory because I know it's written down, that's making me dumber, right? That's giving me less of the opportunity to try to like ruminate on something or remember it. I'm putting it somewhere else. People also do this with each other. So even without machines and any of this, people can start to share a memory. They can start to share this information that they've offloaded to the other person. They have half the puzzle. I don't think that makes us dumber. I think intelligence is a very weird concept in general. It was created, in a sense, by a bunch of terrible people that like to make tests. But implicit in intelligence to me is creativity, right? When we think about like what makes somebody sound smart, it's really their creativity, which is why we're really pushing that angle with our product at least. And so there is a danger that we just over rely on these tools and then we stop doing some of these cognitive functions. But I think we're actually really taxed right now with the amount of information we're trying to keep in our minds, and we literally can't. We just computationally cannot do it.
All right, we're at time, but we should keep talking about that afterwards. Thank you very much, everyone.
For our final session for the day, we are actually going to be elaborating a little bit on what Alice and Linus just spoke about, which is how do we represent ideas and how do we use those representations to better inform operations on those ideas and thinking about those ideas. And so to that end, Esther Dyson will be joining Jerry to talk about idea dimensionality and thinking about thinking. So yeah, without further ado, we have Esther and Jerry.
Up? Good.
Let's see.
Awesome. Come on forward, everybody. We're reconvening for the last session of the day. It's a little bit of a reunion. My boss from 92 to 98 is sitting here. It's kind of fun. I'm really sorry we don't have a larger chair for you so you can take your shoes off and tuck your feet up under.
I'll probably do that anyway when I get, if you ask me good questions.
Excellent, excellent. And I'm really happy because I didn't expect Esther to be able to be here all day, and she's been listening to the sessions, and so we have a lot more to work with than just, hey, what do you think about tools for thinking? So I kind of just wanted to start with whatever stuck out for you during the day, and maybe even the last question about time, or something like that, and just dive in someplace.
Well, actually, I want to start out slightly differently, just for the record. The disclosure, blah, blah, blah. I'm an investor in addition to having been Jerry's boss. That was fun. And it really was. And it's nice to see you.
Thank you.
I was an investor in and on the board of Evernote. I'm currently an investor in a company called Abridge.ai, which is used mostly to summarize and bring out the main points in conversations between doctors and patients, which is really interesting. And honestly, the cool thing about this is part of the business model is University of Penn is using it, and apparently they have persuaded their insurance company to lower the liability premiums because they have a record of what the doctor actually told the patient. And just it's fascinating. But there are some really interesting business models in this area, in addition to amazing science. And then the third one, oh dear, I will come to it. I'm an investor in Hypothesis, which was mentioned as an annotation company. There are probably a few more, but it's a fascinating area. And
is the second company related to Wellville at all, or is that?
No, Hypothesis. Somebody mentioned it this morning.
The one.
Oh, Bridge.ai.
Yes.
No, Wellville is a 10-year nonprofit project, and we are very careful not to use it as a place to promote products I'm an investor in, and so forth. I actually want to start with just something that happened to me when I was 8 years old, and we can. So I was trying to get off the school bus, and I suddenly had what I later found out was an ocular migraine. And what it really wasn't in my eyes, it was in my brain. So, and this presents in different ways, but when you look out in the world, you see a 3D world, you recognize objects, you differentiate things, sometimes it's fuzzy, sometimes you look hard at something, can't figure, oh, it's a lanternfly or something. I did not lose binocular vision, but what I did lose was the ability to construct a 3D world. So the bus driver was here, there was this pole, it was really strange, especially since I was 8 years old.
And you couldn't sort of judge where to reach?
I couldn't create it. It wasn't even judge, I mean, I knew about the pole with my hand, but I couldn't construct that. It was really strange, as you can imagine. My brother got me off the bus, I lay in the grass, my stepmother came and took me home, and then I kind of blacked out. But I've always remembered that. And so I've always been fascinated with dimensions, and more than that, with the ability to construct dimensions out of, fundamentally your vision is 2D. And, so it makes it easier to think, well, could you construct a 4D world plus time? And we can't because we live in a 3D world, but maybe we could start thinking in a multi-dimensional world. So I was especially fascinated by Linus's notion of what I consider, I love quadrant charts precisely because they're about dimensions, how you can move. And this is an interesting thing. Most of their search about topics or subjects or things, and then it's much more complicated search about actions, basically about changes. What companies did Walmart acquire versus what companies acquired Walmart, which ain't gonna happen anytime soon. There you need some language understanding, and it gets more complicated. But anyway, that just wanted an interesting preamble.
Sure. Do you have a sense that there are a couple fundamental dimensions that we need to be serving as we model user interfaces to start to connect to and use all this information? Is there like a canonical set of these that we should be concerned with?
Yeah, I mean, again, Linus kind of started with it. Clearly, time is one of them. And, project management charts, things depending on other things. So there's time and simply sequence, which is
timelines.
Yeah.
Histograms.
Right, all that kind of stuff. There's what you have in the brain where things refer to one another, and it's very nicely, extremely undoctrinaire about what those lines mean. But you can also imagine one that, things refute things, things support things, and maybe they're on the left or the right or up or down. Things that add more detail and things that summarize. The notion of blocks, I don't really like, because ultimately a block is like a PDF, it's a thing, and one thing points to another, but what you want to do is point to the things inside the block, or to create structures. You need more architecture inside, and there you have like a picture of a house, AI recognizes it's a house. Or the AI recognizes, well, it's a house, it's made of wood, it has glass windows, it has 3 chimneys. But then what's really interesting is actually, if the wind blows this way, the house is going to collapse. But if it blows in that direction, it's going to be okay because the strong beams are facing into the wind or something like that. But the notion of structure as well as just spatial representation is extremely important. How strong are the beams? Which beams hold other beams? Which beams support beams?
So it sounds like you're interested in sort of the logic of the structure. So if you're in a sailboat, there's things about points of sail and things that are going to happen to the physics of the wind and the boat that you understand to make the sailboat work.
Right, or if you are, somebody's doing a job, you want to understand where are they strong and where are they weak, or the structure of almost anything. What are the things that support the other things? What are things that you could remove without changing anything? Like the 3-legged dog is still a dog, just is missing a leg. That kind of stuff.
My wife and I did a lot of yoga over lockdown, which sort of got us through it. And the thing we were listening to was like, find a 3-legged dog, and there's like a 3-legged dog in our building. So I'd always just bust up at find a 3-legged dog. So the question about blocks for me is something I call nugget size.
Yeah.
Because I'm really interested in sort of, a nugget is like a whole lot of information. It's a self-contained little piece. It could be a tweet, it could be a thought or a sentence. And then how do we zoom in and out of those spaces so that we can see what's around in the neighborhood?
Or turn them into Legos that, again, hold something up or leave a hole in the middle. Or
exactly.
Yeah.
Or that modularize into an argument. And if you look at argumentation theory, there's kind of a way of doing, here are the pros, here are the cons, here's the statement, et cetera. And we're not very official or formal about any of this stuff at this point. There's a couple of tools that take a sliver of this space and try to formalize it, but we don't have a general theory of this that I know of.
Interestingly, I think one place that might, law. In theory, law is structured, consistent, defines things.
In theory.
And yes, in theory. I've spent a lot of time in Russia, which is an interesting thing in itself, but in Russia in particular and in other places also, I think if you actually looked at enough laws, you'd find a lot of inherent sort of logical contradictions and loopholes and that kind of stuff. But law is an example of where language usually obfuscates. I mean, law is a great example of moving across the spectrum of Linus's thing from you shouldn't steal to 89 pages of what you can't do, that you can't understand, and how it's good to be specific, but it's even better to be concretely general in a way that can be easily interpreted.
Have you seen Lexon?
No, sounds...
So it's a legal language that's based on solidity, I believe, and it's an attempt to create a machine and human readable legal language for smart contracts and all that good thing. And it's pretty interesting. Has anybody here worked with Lexon? Nobody. Okay.
And it's the company called Lexon.com?
Their website, if you can put my screen up top, Lexon.tech is it's an NLP company, and they're busy trying to figure out here's a new type of program language that anyone can read, all about legals, contract. And here's a Lex escrow. Contract, exactly.
Yeah, I mean, it would put lots of lawyers out of work, and they're mostly smart people and could do something useful.
Well, we're going to replace them with AIs anyway, right?
Yes. Yeah, well, exactly. This is but let's have them do something better.
Yeah. Well, everybody who'd like lawyers to do something better, raise your hands or do the thank you. And so, is technology making us dumber? I wanted to head back into that question.
Yeah, that is a really interesting question. There's another angle, of course, a different dimension to that question, which is as you get older, so they tell me, I would never know, you begin to forget things or you can't remember things. And the polite version of that is, oh no, you're not losing your memory. It's just there's so many things in your brain, they're getting harder and harder to find. It's like trying to find a sweater in a stuffed closet versus in the suitcase where you packed only 6 things. And I really like that explanation, but it certainly makes you pay less attention to trying to memorize important things. I mean, if you go to a conference and you know people are going to be wearing badges, you don't bother to learn people's names. And you can argue that that's actually pretty sensible. I mean, I remember all kinds of useless stuff, like phone numbers from 20 years ago, and if I could forget that and remember the name of the person I met this afternoon.
I'll borrow something from David Allen, the Getting Things Done guy, who talks about open loops, how we have all these open loops in our head, and they occupy a lot of our attention and time, and the idea of his system is get these open loops out of your head into a reliable system you will always come to next, and it will feed you what the next task is, so you can stop holding all this extra stuff kind of in limbo, in like long short-term memory. And I like that a lot. And
as long as it's reliable.
And the reliable system thing is really important there, right? Because if you're not looking at it, or if you don't use it, or if it goes away, then
or you're not reliable at finding stuff in it.
Right. But the idea of letting those things go from your head is great. I like that a lot. I mean, my outboard memory lets me let go of a lot of things because I know I'll find them again, because I've had the experience over and over again of trying to Google for something and not finding it. It's like, ooh, I thought I remembered it. And then I've got it kept here. And if the link broke, I go to the Internet Archive and I use the Wayback Machine, and usually it rescues the piece.
Yeah.
So that's kind of nice.
Very. Though, I mean, there's also psychology there. So I have an interesting thing of never wanting to call people. Well, I usually wouldn't say hi, Jerry, or hi, Linus, because when I was growing up, my parents were divorced, and occasionally I would call my stepmother Mummy, which was no problem. But when I called my mother by my stepmother's name,
that was a problem.
It was a big problem. So I'm very risk averse in that particular thing. And what it means is I'm not very good at learning people's names because I don't intend to use them. So it's
makes good sense.
It's an interesting, we need to remember how complicated people are versus an AI.
So would you wear an AR system that would identify each person with a little name tag next to them? You'd be good. You'd be up for that.
I'd be good. And I keep trying to call the lifeguard in my swimming pool by her first name, which is Naira, but it just feels so forced to me.
That's super interesting.
Yeah.
So among the tools for thinking space and a lot of the time you spent in software and all that, going back to kind of the earliest days of people trying to figure out if we're going to be able to sell software and make a living, right? What's your trail through this, or what are the marker points that you like to look at?
So less about the past, more about the future. I think we're still talking about helping one person's brain and not. There's Slack and there's workflow, but how can you, again, I go back to David Waltz, words are not in themselves carriers of meaning, but merely pointers to shared understanding. And especially, I would say the AI's words, they really don't have that shared understanding. They've not learned something, they've been taught something. They might have, how shall we say, iterated something, which we look at as learning. But how do you create the shared understanding in this thought space among people working on a task? And part of it is, yes, the Slack notification goes to the right people, but to build a real shared understanding, which is a complicated, multidimensional thing with different people interacting with it at different times and updates, and the thing is, updating does not mean adding data. One interesting example, there was this guy who is still around called Jeff Jonas, who started his, did you meet him?
Oh, long ago, yeah. He was living out of his car for a while.
Yeah. He lived in Las Vegas, and he had this tool for casinos who would lose their license if they let in a known felon. So they were very interested in knowing who people were. So he built a database of identities and so forth. And the interesting thing, well, there were two interesting things. One was the database grew to something like 600 million Americans, which is slightly more than there are. And that's, of course, because of the duplicates. And his database got
I thought he was finding
better.
like the shadow population.
Yeah. Well, yourself at all these different addresses. So the database, as it got better, it actually got smaller, which was really cool. I mean, there was a little more data in it, but there were fewer people because the people turned into the single person. And the second thing was just a question of design and design and implementation of how it worked. Every time a casino would put in a query about a John Smith, that query also turned into data because the particular data of that John Smith was then added to the database and ideally, you know, again, deduplicated at some point.
Right.
But how you, it's that kind of thing that you want to put into a shared understanding or a shared view of some problem or something like that. And how do you, if people are working on a development project, how do you make sure that they're all working on the same version, that when somebody goes away for 2 weeks and has some brilliant ideas, they get incorporated, and again, not just added, but they alter some of the rest of that information structure that has been collectively created.
And if these people have good intentions and are leaning in toward each other to try to do this together, that's already really complicated. So never mind when some of the actors in the arena are busy like denying facts or turning things upside down. I mean, the moment you pull this up into the current political arena,
that's an even tougher question.
It's really, really messy.
There's one thing I thought of while people were talking. So DNA versus metabolism is and DNA is, so it's kind of what you're born with and it's your ID. And a lot of people are looking for, well, who produced this piece of news? What was the source? Is it reliable? And there's a huge amount of obfuscation. And then a more interesting way to look for it, take the analogy of cancer, is closer to a PET scan than a blood test. So a blood test looks for these little molecules of, little globs of cancer. A PET scan basically looks at the metabolism. What in your body is absorbing unusual amounts of sugar, of nutrition? And that's likely the cancer because it's growing faster than anything else if you're an adult. Or you have, unless you have a wound being, you know, wounds healing. Speaking of words coming in and out of your mind. So in terms of information, it's the money flow typically. And I get lots of right-wing spam because I kind of enjoyed looking at this stuff the way I like to look at the weather. You know, it's just like what's prevailing. And I went to wonderful Miss InfoCon once, and to their credit, they had a Miss Info guy there talking, and he said, "Oh, you know, I'm really not political. It's just this stuff makes a lot of money." And whether it's somebody trying to make a lot of money or somebody with a false view trying to promote that view, I mean, ultimately it's money or power or something, but it's like it's not a natural metabolism of people making their own decisions. It's a manipulation. So when you look for perturbations in the sort of the statistical metabolic flow, that's where you find people who have a vested interest in selling something rather than simply expressing themselves.
Solving something or expressing something. What would you measure or look for to try to figure out the metabolic presence of thinking in an organization?
Thinking in an organization.
And are we?
I sure.
Are we
yeah,
thinking?
I mean, I sure wouldn't look at people.
It's like, how do you?
Yeah, I mean, the metabolic thing is when there's a distortion, when somebody talks way too much rather than sits at their desk thinking for themselves. When somebody's pushing something or, you know, trying to flood the airwaves with their thoughts, or
that darn postal worker who keeps writing physics paper. Einstein.
oh, right, okay. Yeah, but he didn't post, I mean, he, whatever. The point is, the people who promote themselves beyond,
Patent worker, sorry.
yeah. Now I get it. I didn't remember the post.
Sorry about that.
Yeah, it's okay. But it's, again, you look for unusual behavior, which can be represented as, you know, somebody's got an idea versus somebody's trying to promote an idea to get promoted into their job, or
Right.
just where are the abnormalities beyond what is in the content, how the content is spread or used or monetized or just pushed out, or, you know, interestingly, if you look in a corporate structure, who are the people nobody talks to?
Right.
Like the owner's grandson, who's got a high position, but nobody really wants his help, other than to get promoted.
And some of these energetic dynamics are metastatic. They're like cancerous in the organization, but some of them are just excitement and like somebody's off and racing on something. And I'm sitting here wondering from the last session that was right here, like, could these machine learning models distinguish the difference between those kinds of activities just from watching a Slack channel or email transmissions?
They probably could, and it's an interesting, I mean, again, one part of me says that's great, another part of me says, geez, I don't want to be surveilling everybody all the time.
Exactly.
But you can, it's amazing what you can find when you look at data. And certainly, I mean, again, I'm thinking about something, there was another company called Catafra that would look at emails and who responds to whose emails, who does not get a response, who always CCs his boss, who gets left off the chain, who's engaging in conspiracies, and then of course who takes secret information home to their.
Not that that's happening recently.
No.
So I want to invite questions from all of you, and we have one immediately. Sorry to spring that on you. You'll have a mic in your hands in about 15 seconds. Please say your name before you ask your question.
Hi, I'm Chris. Thank you, Esther. I thought this was great, and I wanted to ask about the relationship of trust in thinking in these systems. And so, you know, just, as a point of context, I teach a course on creative thinking at the undergraduate level. One thing we've learned over time is that it takes about a month to develop the trust among the students to actually start practicing the process. Because in the first 4 weeks, you're like, what are uses for a brick? And it's crickets, right? And then it's, oh, a construction material, right? It's safe, because what they're doing is like the cognitive load if they're gonna say something that people judge them for and think that puts them at risk is so fearful that they can't even think about the new ideas. And so I'm curious, especially with your investment in this, in the doctor-patient era of expertise, right? Where we're actually trusting someone to think for us on our behalf around an issue we're having with our health. Like, what happens to the doctors when you introduce these tools? They're like, I don't want to do that, or does it actually help them be better at diagnosis and they're accepting, or is there a learning curve with that?
Okay, so I'm not sure which level you're asking this. Trust, so.
Is there a relationship of trust with how thinking
Well, there certainly has to be trust in the tools you're using, the people who are using them, the institution that gave them to you that is collecting your data and what you think might be happening. But to go sort of beyond that, I believe we're all in here white and Asian, and one or two of us are female. So just in Muskegon, which is where I work with my nonprofit, I talked to two separate Black people about getting vaccinated. They're both in healthcare, and so that, you know, they believed in vaccinations, but each of them told me separately, I know the vaccine is good, but I still just felt safer standing behind a white person. in line to get vaccinated. And so trust is very much a function of an individual's past experience, both in general and with specific groups or people or whatever. And it takes, what's interesting here, and I was really interested in Alice's background in particular, AI and neuroscience, I have the same folder for both of them together, because ultimately they're a spectrum on some quadrant chart, how people's minds work and how AI ultimately should start working. And everything from recognition of objects to constructing meaning and so forth and so on. And trust is a different dimension, but it's also a human one that you can make a system more or less trusting. How much does it ask for, again, whether it's DNA or metabolism, how much evidence does it need to trust some source or to trust anything it's dealing with? I'm not sure I'm answering your question.
I'd like to take a swing at answering it also. And if Howard were still with us, he learned over time with his classes to have the kids design the curriculum. He was like, here's the deal. You design the curriculum, and he would give them as assignments, and they would present to each other. And not in the teacher not getting paid enough, going to go sit in the corner and read a novel mode, but very much trusting the students to do that. I, over the last 35 years, have found my way to a thesis that we've been designing all of our institutions out of a mistrust of the average person, which is wrong and broken. And when you flip that around, a thing I call design from trust, you actually get institutions that reconnect people, that let people sort of participate, that give them back their sense of agency, responsibility, interdependence, all the things that sort of the consumerization of our lives have cut away from us. And so we don't notice this. This is just background radiation. So I'm pointing here to the hidden curriculum of school, which is one of the first ways I learned this, because John Taylor Gatto, who I got to meet in New York, was a retired high school teacher. He was saying, nominally I'm your kid's English teacher, but let me tell you what I was really teaching them. I was teaching them that I'm God here in the classroom. They're going to learn their place in the order as a little cog in the system. Nobody trusts them. They can never be alone. They need a note for everything.
And they can't collaborate. That's cheating.
And collaboration is cheating. And he used to get all these awards for best teacher, and then he gave up teaching because they would send observers into his classroom and all that. And the way he was winning awards is he was breaking all the rules of teaching. He was sending kids out on the street to sell ads to the local merchants. For the newspaper, he was making them write to the standards of the New York Times, for example. And so you can run this lens over just about all our institutions, and we've lost faith in humans. And so that's baked into software, it's baked into everything we talk about in all these different kinds of places. Exactly. And so flipping that is really uncomfortable when we hit a system that's designed from trust. Like, who remembers the first time they used Wikipedia? Probably, maybe not the first time, but almost everybody uses it regularly. Who remembers the first time they realized how Wikipedia works? That any idiot on earth can go change a page on Wikipedia and hit save, and there it is, right? It's like, whoa, did your sphincter tighten? Because that's an act of trust. And Wikipedia leaves the keys in the car and says, come on in, and if you make a mistake, we'll just hit revert, and then we'll try to bring you in to do this the right way. That's really interesting and completely upside down from even the way Wikipedia started. Originally, they hired editors, they had a 7-layer editorial process that was failing.
It's got a little more governance than that.
Oh, and now it's got history, crust, like a whole culture.
Yeah. And editors and non-edit, whatever. But another wonderful example of what Jerry just said is Esther Michalski, who teaches journalism at Palo Alto High School in much the same way. And a lot of complaints from parents originally when she started doing all these irregular things, but now she got awards from other institutions, and so now they respect her.
Right, exactly. Exactly. So other questions? There's 2 in the back there.
Hello, my name is Kevin. Thanks for the discussion. This is fascinating. I was thinking a lot about, there seems to be sort of a general theme, especially around language, about sort of sanitizing the interpretation element of language in order to create, I guess, something that is meaningful equally across multiple people or experiences. And I really liked the legal contract as an example of this. Because I think when you create a legal contract, the lawyers get paid the big bucks to sort of make sure that each party is interpreting it the same way. And when a contract falls apart and they have to go to court, that's, if it's in good faith, and I guess that wraps around to the trust conversation. But if it's in good faith and the contract falls apart, they go in front of a judge, and the judge supplies his own interpretation of the contract and says, well, you're correct and you're wrong, or maybe you're both correct and this is a bad contract. But that's, in my mind, that's what makes law beautiful, is that interpretation element. Because when you strip interpretation out of the equation, I think that's how you get dogma and belief systems built on sort of what is meant to be the only way to interpret something. So yeah, I was just curious what.
Gil, that is a complicated question / comment. Esther, do you want to pick it up?
Yeah, I'm still not sure what the question is.
Sorry. Well, maybe.
Just give a better prompt.
Yeah, sorry. I'm starting to come around to the idea that maybe it's better to lean in to these sort of interpretive. The interpretation of it, when I saw Linus's model, the first thing I thought was, oh, this is a way to like create several different explanations of the same thing and allow someone to find the one that resonates with them and connects and creates that meaning. So in a way, you could sort of be quantifying intention in the communication. As far as communication goes, in my opinion, the intent of the communication becomes irrelevant to meaning.
So I mean, maybe Linus should answer. I think there's one version where it's a simpler or a more complicated statement of the same thing, but there's another dimension where it's this happened slowly versus this is a story about something over several weeks, or this was in an atmosphere of friendship and trust, or this was in an atmosphere of suspicion and so forth. So there was definitely one such dimension, but not all. Mm-hmm. And I mean, I always like the example of, you show a picture of a woman, and to some people, oh my gosh, it looks exactly like my mother. And to someone else, it looks like my girlfriend, or it looks like, some white lady and I'm black, and so I don't identify with it. Then you can abstract it to something that does look like all mothers. And, so there really are different levels of abstraction and generality versus specificity, and they're real. They can't be abstracted away. And the purpose of a legal document is to try and try and figure out what the range of possibilities are that it could apply to. And then the purpose of somebody trying to get around the legal document is trying to figure out exceptions.
Mm-hmm. Taking a different angle in, I put the following sentence up just because I think it challenges your notion. A well-regulated militia being necessary to the security of a free state, the right of the people to keep and bear arms shall not be infringed. Hey, nobody can seem to agree on what this sentence says. Right? And there's a major shit show in the public stage about just this one, never mind a whole bunch of other issues like that. So I'm unclear that, and I think that the fight over language is intensely important and central to how our cultures evolve and change paths and all of that.
Yeah, but it's not the fight over the language, it's the fight over the meaning.
The framing around, it's just words.
But it ain't.
Yeah.
That depends whether you're a constructivist or a...
Both. We had another question right next to you. Thank you.
Yeah, just
Court is adjourned.
I found it very interesting.
Your name, please?
Sorry?
Your name,
Andre.
please. Thank you.
So for me, trust is always in context. So trust is in context with the power structure that is there, and also on how resilient the system should be. Right? So if you talk about Wikipedia, for example, it's actually not that easy to change certain articles because there are editors that might have a different opinion than you, and everyone else, for that matter, have a disproportionate amount of power. There are situations where you have a high trust environment where you can trust people to do that because there are ramifications of, if you don't do that, your social capital is diminished. If you don't do that, other things will happen to you outside of the things.
Consequences.
Yeah, there's consequences. And in specific an example that you brought with the school, there's a power structure there, clearly, right? So the question, how do you manage, how do you compromise in the right way, in the right abstraction for the kid?
Is that a question?
That is not a question, but how do you see...
We're really good at hunting down questions.
Yes. So how do you see that tension playing out? How would you design a thing? So assuming that your position is that more trust is better, how do you go towards that? How do you navigate these other parameters that play into that?
Sure. I mean, it's different in each domain, whatever thing you're looking at. But part of it is learning how to read what I call the architectures of mistrust. So one of my heroes is Hans Monderman, who kind of invented traffic calming, which is now also known as shared spaces. And I visited him in Holland. The picture in Wikipedia of Hans Monderman I took way back when. And he was busy saying, hey, those affordances we think raise safety, in fact, decrease safety. And part of what he was doing was showing cities how to thoughtfully redesign intersections to improve flow, reduce accidents, and rebuild community, because when you have to time your passage through a roundabout with bicycles, cars, and pedestrians, you better make eye contact or you're running somebody over. As opposed to, I'm in a BMW 5 Series, it goes 95 miles an hour, and I've got a green light, I'm just gonna floor it, right? So and for each domain it's different. And so trying to understand how to go about that and what to dismantle and how to redesign it is really a big deal.
I guess I'd add two things. One is to be trustworthy, and the best way to do that is to be transparent. It's like a private person who asks nothing, their privacy should be respected. But the moment you start asking people to trust you, to give you money, to give you power, to trust you in school, the teacher, they need to provide evidence of their trustworthiness. And so transparency is, again, it's the spectrum of privacy for the powerless, transparency for the powerful. And it's well known, if it just psychologically, if you want to get people to trust you, you tell something private about yourself, not in an obnoxious way, but just the more real you are and the more you share your own motivations. I mean, I find the best way to bargain is always to tell people what you're willing to get, because then they know, both sides end up satisfied, because if you ask for more than you actually need and they say no, you end up not getting the thing you wanted, and vice versa.
Other questions? We have room for one or two more. Over on the far side of the room there.
Hi, I'm Michael. Esther, you mentioned in the beginning that the block as it does not resonate with you, and I'm curious, I have always seen it as the most atomic unit of thought, and I'm curious if you could expand why you don't like it.
Well, it's not that I don't like it, but it's not sufficient. It's precisely because the interesting thing, take atoms. So you combine hydrogen and oxygen and you've got water. But if you look at that atom, you don't know if it's wet. You have to look at a bunch of water. Sorry, if you look at that molecule, you don't know if it's wet. You have to look at a bunch of molecules and how they interact. And you also need to look at, water is very different from a bunch of hydrogen and a bunch of oxygen. So it's not sufficient. And what's interesting is not this block is next to that block, but what is it that connects them? So there's nothing wrong with blocks. They're just not sufficient in themselves.
But even though they do allow you to start constructing that relationship.
Oh, they're totally useful, like Legos, but Legos are designed to build things. They're not designed just to be on the floor in a mess. And so, you know, many of these, it's like a search tool. The difference between an address book, which lists all the addresses, and they're in order, but the order is not inherently meaningful, though it makes them easy to find, and a map, so you can see, well, this house is next to that house. This house is next to the park and is worth much more because it has a view of the trees. And so it's the arrangement that adds the meaning that helps you find things. And oh, that's the company I forgot. So
oh, good.
Yeah, I'm also an investor in a company called Zeotag, and the line I gave them, which I still think is brilliant, is Zeotag does for basically they automatically transcribe and then structure and segment and outline conversations, Zoom calls, you know, sales calls. What was the moment at which the customer began to lean forward and start to accept the pitch? So anyway, I said they do for video what Google Maps did for an address book. And that's it.
Cool. One more question.
Hi, Jason. Thank you so much for talking. It seems like a lot of the challenges you've been describing is the homophone problem, the difference between there, if you've ever been in an 8th grade English grammar class. So I'm just curious how you think about the controversies of homophones.
Do you have an answer? I can't bear this bear of a question, barely.
God. I don't know that I've been party to that controversy. It's and also like these machine algorithms and so forth are operating at pretty good levels of disambiguation and all that. You look at auto-suggest and spell check, even understand the difference between there, and there at a pretty good level. So I'm not sure I'm aware of the homophonic discord that is afoot. Esther, thank you. This has been delightful.
So, yeah.
Yeah, we turn the floor back to our hosts and we go from there.
All right, well, that concludes our programming for the day, but it certainly does not conclude the conversation around tools for thinking. As I mentioned earlier, the reason why we put on these events and these conferences is because when we feel that there's a critical kind of mass and interesting inflection points behind a particular category or technology, we want to bring a lot of like-minded people together to talk about it and to continue talking about it. And so, to that end, while today's programming is ended, we are working on to put on further activities and events with other thinkers in the ecosystem, other entrepreneurs in the ecosystem. So we'll be reaching out shortly to everyone for what's coming up in the pipeline. And I'll also mention our camp program one more time as well. Beyond just allowing kind of companies to come in and tell us what they're working on, we like to actively back those companies as well. And so if you're working on something or know someone working on something in the tools for thinking space, we'll be running an accelerator program, which we call Think Camp, starting this September in just about a month. And so you can go to our website to learn more about that and apply online. Yeah, with that, John, do you have any final statements or thoughts?
Yeah. I think this was a great day, so thank you all. Thanks for joining us today. I really appreciate it. I love the fact that we spent, much of the last 45 minutes talking about language, which is sort of our original tool for thinking, I think, as a species. I think we figured out there's a there, maybe. And I think that, I mean, the day was great. I'm not going to do a recap of the day, but think about this very much as a starting point for us, and hopefully for many of you to be on this journey with us. You know, as Neil said, we've got the Accelerator program coming up. Jerry's going to host a weekly podcast, Zoom, where he's doing discussions and interviews with builders who are creating new tools for thinking, so that each week we can get something new out there. And we'll do a host of other things around that, which will sort of develop organically. We may do another session like this in the fall or in the winter. But I think that the purpose here is to start to get people together, to expand the tent and give people a sense it's a big tent and there's a lot going on here, and also to invite people into that and see if we can get people building more stuff here, because there's so much here which I think needs to be created. So thank you.